Hey everybody, and welcome back to another fun and exciting Algebra 1 class. In today's lesson, we're going to jump into chapter number 2 in your book, and that is on page number 30. Page number 30, so properties of equalities. So go ahead and look over there in your book. On page number 30, we're going to find that the book starts talking about these things called equations. So maybe you're thinking, yeah, I think I know what an equation is. It kind of sounds like the word equals, so equals, equations. Maybe these are similar. Well, you're on the right track. An equation is a mathematical sentence that states that two expressions are equal. For example, the expression of x plus 3 equals 10 is only true when the value is 7. So if x equals 7, then this is true. 7 plus 3 equals 10. If you put any other number other than 7, 5. 5 plus 3 equals 10. That is not true, so that is not an equation. That is not equal. Equation and the word equal are the same thing here. And so you have to have an equals sign, and you have to have the left side is equal to the right side. The whole thing has to be equal. All right, let's look at one of the examples over here on the blackboard. So they give us 5x minus 2 equals 8. And now kind of what they're asking you is they say, determine if x equals 2. Is that true or is that false? So what they're asking for is x equals 2. So this is what they're wondering. Does x equal 2? Well, the way that you find out is you basically take this 2, and instead of the x, so this is an equation, right? So this is equals. So if the x equals 2, then over here where the x is, guess what we can substitute in there? We can put the 2 in there. So now we have 5 times 2 minus 2 equals 8. Is this true? 5 times 2 is 10, minus 2 is 8, and then you come up with 8 equals 8, and that is a correct answer. So that checks out. In other words, x does indeed equal 2 in this situation. All right, then they do another one. We can do that one over here. It's x plus 3 equals 6. So x plus 3 equals 6. And they say, if you substitute the x for 2 again, does that work? So if we do the same thing and use this 2 here, 2 plus 3 equals 6. 5 equals 6. That's wrong. And so this whole thing is wrong. So in this case, 2 is not the correct answer. Okay, so that's all that they're asking you to do there. All right, if you will go ahead and turn over to page number 31 in your book, page 31. And it starts talking about equations are solved by what's called isolating the variable. What in the world is isolating a variable? Well, if you're isolated, you could be isolated in prison. You could be isolated on a deserted island. Basically, it's you're by yourself. There's nobody else around you if you're isolated. Here's what we want to do. We want to isolate the variable. Do you remember which one the variable is? Okay, the variable is the x. It's the letter. So you want to get x all by itself. So you want to say x equals something. Okay. And if it's not x, that's fine. A equals something, y equals something. Doesn't matter what your variable is. Whatever the letter is, you want that all by itself. All right, so in other words, if they say x plus 8 equals 3. What we need to do, and this is a little trick that we'll learn in just a second. I'll tell you what it's called here in just a second. But if you go to x plus 8 equals 3, what we want to do is get x all by itself. The way that we do that is we subtract 8 from both sides. Makes sense, right? So if you have x plus 8, if you take 8 away from it, you're left with just x. So if you have x plus 8, you subtract the 8, that cancels out, or that gives you a 0, right? That zeroes out. So now here's kind of the tricky part. If I did it to this side, the left side of the equation, I must also do it to the right side of the equation. We're going to learn what that's called in just a second, but just trust me right now, and you'll see how this is kind of a little bit of magic here, and you'll see how it kind of works out. It's not really magic, but it's algebra magic. All right, so if I subtracted 8 from this side, I must also subtract 8 from this side. Okay, so what do I get if I have 8? Well, 3 minus 8. Well, if you do the math, and you should have remembered how to do the positive and negative numbers right there, we subtract, take the sign of the largest, and that's going to give us a -5. Okay, so what we're saying is all we're left with over here is x. X equals -5. And you say, well, I don't really know if x equals -5 or not. Well, the way that you would figure that out, let me change colors here real quick so you can see this a little bit better. All right, so if you kind of go back through this and do what we did up here, you're going to find out if your answer is correct or not. So if we say now instead of x, we're going to use -5. So now -5 plus 8 equals 3. Now you just do the math. -5 plus 8. The way that you do that, if you don't remember, when the signs are different and you're adding, you subtract, take the sign of the largest. 8 minus 5 gives me 3. The sign of the larger is the 8. It's positive, so 3 equals 3. And that checks out. That's good. So we did something right there. Now you might say, that's kind of complicated. I didn't totally understand that. Well, let's kind of go through this real quick, and we'll just go back over it, and we'll try to learn some of the tricks. To isolate the variable, that's what we just did. We got the variable by itself. Look right here, x equals -5. All right, to do that, what did I do? How did I do that? I used what's called the inverse operation. What's the inverse of something? It's the opposite of something. So if we go back over here and we had a +8, then what am I going to do to get rid of that? I am going to subtract 8 from both sides. So if I do it, again, this is the trick, if I do it from the right side, and then I must also do it to the left side. By doing that, I'm going to solve the equation. Okay? All right, let's look down here at these properties of equality, the properties of equality. All right, so the addition property says this: adding or subtracting the same amount from both sides will not change the value of the equation. What do I mean by that? Well, if we say, let's say if I have 5 plus 3 equals 8, okay? If I add the same amount to both sides, so if I add 2 to both sides, so +2 and +2, okay, watch what we get. So what's 5 plus 3? 8. 8 plus 2 is 10, equals 8 plus 2 is 10. We didn't change, now it technically changed the value of it. In other words, it made it 10 instead of 8 equals 8, but it doesn't change the validity. It doesn't change the fact that it's true, okay? 10 equals 10. 8 equals 8. It didn't give us a wrong answer. Now, watch what happens if I only do it to one side. So let's say I only add 2 to this side. Well, I get 10 equals 8. That is now a wrong answer. And so if you add 2 to one side of an equation, you must also add it to the other side of the equation. Think of it like this. If I have a seesaw, right? So I've got one of these little seesaw things, like a little balance, okay? And I put one person on one side. Let's say they weigh the exact same. I'm really good at drawing. Art is one of my main things. So you probably figured that out by now, right? Like, okay, I'm not an artist, okay? So don't make fun of me. All right, so here we go. I have my second person over here, okay? Now, he's got a little bit bigger head, but it doesn't matter, all right? I'm telling you, they weigh the same amount, okay? Exact same amount. Well, what happens if I add a person to the left side, but I don't add a person to the right side. So what happens if I add a dude over here and I don't add a dude over to the other side? Well, that seesaw is going to basically it's going to tilt down, right? So you're going to take that and you're going to it's going to start going down. It's going to be unbalanced, right? In order to balance it, what do I need to do? I need to add a dude to the other side. Once I do that, now we're back to balanced. We're even again, okay? So that's the trick to this. If you do it to one side, you have to do it to the other. Now look, here's it says the same thing about multiplication. The multiplication property says that if we multiply or divide by the same amount to both sides, notice it says both sides, the value of the equation will not change. Okay, so the equality does not change. So we can do these things. These are tricks to help us solve these equations. All right, let's do just a couple more equations here real quick. We'll do another one from your book there, example 2.1b, which is on page 31. So if I have x minus 6 equals 13, how do we solve that? So what's the goal of the equation? The goal of the equation is to get x all by itself. So I need to take the 6 away. I need to get the 6 to the other side. So if it's a subtracting 6, what do? I do the inverse. I do the opposite, which is plus 6. If I do it to one side, I must do it to the other side. I must also add 6 over here. Well, look what happens on this side. The minus 6 and the positive 6 cancels. That's what you want. That's the goal. So I end up with x equals 13 plus 6 is going to be 19. My answer is x equals 19. Now, I'm not done technically. Here's what I want to do. I want to verify, is that true? Go back to your original. X minus 16 equals 13. We need to sub 19 in for x. 19 minus 16 equals 13. Is that correct? 13 equals 13. We are correct. Okay. All right. Last thing, and then I'll leave you alone. To eliminate fractions from equations, simply multiply everything by the LCD, least common denominator, or you can also multiply by the inverted fractions. So this is on page number 32. So you can go over there to page number 32. Let's look at one of these examples. It says y minus 3/5 equals 1/3. Now, here, let's use the LCD method. So the LCD of this, technically you could put this y over 1 if you wanted to, because it doesn't change the value of the y. Anything over 1, it's an identity. Remember, we learned the identity principle. And so what is my LCD of this? So I have a 1, a 5, and a 3. All right, my LCD is going to be 15. If I multiply everything by 15, I'm going to eliminate the fraction. You'll see in just a second. So I'm going to get 15y minus, and then we basically 15 over 1. So we're going to get rid of this, and this will cancel down to a 3. 3 times 3 is 9. And that's going to equal, and we're going to cancel this one to a 5. And so it'll be 5 over 1, or 5. And now, notice I've got a new equation with no fractions. It's a little shortcut. It just helps you eliminate fractions, helps you solve these a little bit quicker, maybe a little bit easier without all the fractions going on. All right, so I now have a 9 over here. Again, I'm trying to get this all by itself. So if I have that 9 over here, I'm going to add 9 to both sides. Okay, and that's going to cancel, and I'm going to get 15y equals, and that's going to be 14. Okay, and then if I divide both sides by 15, since this was multiply, do the opposite, and do this one. Well, this one cancels out. 15 divided by 15 is 1. And so I get y equals 14/15. Okay, and that would be my answer. There is another thing that you could do. It's not really a shortcut necessarily, but it's the second method. You can also multiply by the inverted fraction, and this works when you only have one fraction. So if I have like 2/3 x equals 8. The way that I can do this is I can actually take this fraction right here and I can multiply it by the inverted fraction. What's the inverted fraction? It's the flipped fraction. So now I can multiply this by 3/2. But remember, here's the trick. If I do it to one side, I have to do it to the other side. So I have to multiply this times 3/2. Okay? Well, what happens here? Notice this all cancels, and so I get x. X is by itself. That's what I wanted. Equals, and then I would just do this. So 8 times 3 is 24/2. Reduce that down, and I get 12. So x equals 12 would be my answer there. So just a couple different ways. I told you I was done. Let me give you this real quick. And this is just gonna kind of be one of those things to put in your brain. There's not really we won't do any math with this, but tips for solving word problems. Now these are going to be word problems that involve equations. The way that you do that is, number one, you read for understanding. Then you represent the unknowns. You create, like, okay, what's the x? What's the y? What's the unknown? Okay. And then you write and solve the equation. So you just kind of write it out. Remember, we learned this in a previous lesson. And then number three, you just state your answer. You say x equals 2, whatever it is. And then notice, please check your answers, because you're going to find out that in algebra, you can know, like on an algebra test, you can know if you got it right or wrong, because you check your answers and then you know, okay, I'm right. I know that's correct because I checked this answer and it checks out. The only way you would still get it wrong is if you're doing the check wrong. Like if you did it wrong and then you checked it wrong as well. Like if you're doing bad math or something like that, or your calculator's messing up or something, obviously you could be getting wrong answers if you have like something wrong with your calculator, or your brain calculator could also be giving you the wrong answers. So lots in that lesson, a bunch of different little things, but hopefully they kind of added up there to make a little bit of sense to you. So I'll let you go. If you missed anything there, make sure to slide it back and watch it again. All right, that's all I've got for you. Hope you have a good one. We'll see you later. Bye-bye.